today's lesson, you guys will be working on the properties of logarithms. Okay, so what that means is that there are different characteristics or different ways for you to solve properties or solve logarithms, and I'm going to explain those properties. There are 3 of them today, and it's going to help you to basically manipulate or use algebra to solve your equation. So the first one, if you have the log of base b mn, that's going to really equal the log of bm plus the log of base bn. Okay, so let's look at an example of this. If I have log base 2, 5 plus the log of base 2x equals the log of base 2, 15. Okay, my goal here is to solve for x. Well, I know that the 2 logs added together, the 5 and the x must be multiplied together in order to get my 15. So looking at this, it's like I can cancel off the log of base 2. So I have 5x equals 15, x then has to equal 3. Okay, so for you guys, I want you to do one more of these. Let's say, for instance, I have the log of base 3 of 5 plus the log base 3 12 equals the log of base 3 x. Your job is to find x. Because I'm adding, I know that it's the log of base 3, 5 times 12 equals the log of base 3 x. So 5 times 12 equals x. Looking at this, I know x has to equal 60. All right, so when I'm multiplying, I'm adding. When I'm dividing, I'm subtracting. Okay, so the log of base b m divided by n equals the log of base b m, because that's our numerator, it's the top number, minus the log of base b n. Okay, that makes sense. When we're multiplying, we're adding. In this case, we're dividing, so we have to subtract. Okay. So for instance, same kind of concept applies like the first examples. Log of base 5, 42, minus the log of base 5 of 6 equals the log of base 5 x. Notice, in all of these, all of my logs, their bases are all the same. Just in case you missed that, the bases have to be the same in order to do this, which they will be, but I'm just giving you a heads up for eventually down the road. Not all the time will it be. So anyway, with that being said, I have the log of base 5 of 42 divided by 6 equals the log of base 5 x. So 42 over 6 equals x. Therefore, x has to equal 7. All right. For you, let's say I have the log of base 6 of 36 minus the log of base 6 of 12 equals the log of base 6x. So go ahead and solve that. Looking at this, I know it's the log of base 6, 36 over 12. Well, 36 over 12 equals x, therefore x has to equal 3. And the last one that we'll be doing is the power property. If I have the log base b m to the p, so I have an exponent there, that's going to equal p on the outside times your log of base b m. So I'm just going to start basic here, and then I'm going to show you an example of a combination of all of those, and then you'll get a combination one. So for this, let's say I have 4 log of base 8x equals log 881. Okay, so I know that I can manipulate this side here to be log 8 of x to the 4th equals log 8 of 81. Now, this is going back to the day before. I know that based on the log 8, I can cancel that out and just have x to the 4th equals 81. Well, in order to get rid of the to the power of 4, I have to take the 4th root. X therefore equals plus or minus 3. But. Remember how we went back to we couldn't always have a negative? This is where you need to check. Okay, this negative 3 actually does not exist. So our answer is just a positive 3. Okay. Like I said, I'm going to get to one where we have a couple manipulations. So for instance, let's say I have 4 log base 2x plus log base 2 5 equals log base 2 405. Okay, this is just like algebra. If I were to think of the log here as parentheses, you'd have the same process. So I would really just kind of take it out. You'd have 4x plus 5 equals 405. It's kind of like that, but I got a situation here that's a little bit different based on my properties. So my first step here is to not do that, is to get this log base 2 of 5 over here. Okay, so I know that I have 4 log of base 2x equals, well, what happens when I subtract? When I subtract, it's like I'm really dividing. So right now, I'm going to simplify that 405 over 5, and I'm going to move this 4 on this outside here to be a power. So I have log base 2 x to the 4th equals, well, what is 405 divided by 5? It's 81. So now looking at this, I've got the log of base 2, log of base 2. I can cancel that log of base 2 out and get x to the 4th equals 81. Well, we just did this, so x equals 3. Okay, so you got to manipulate your problem, but you got to make sure that you're using the correct properties in order to do your manipulation. So this one is for you guys. You have 3 log base 5x minus log base 5 to the 4th, not to the 4th, just 4, sorry. Log 5, 16. So x will be one number. Good luck. Looking at this, I know I'm going to move. I'm going to move this log 5 of 4. I'm going to add it over here? Well, I know when I add, I'm really multiplying. Like I was saying, I got to multiply the 4 and the 16. So now I'm going to move the 3 over as well, so it's a power. So I have log of base 5 x cubed equals log base 5 of 64. Because my log 5 is the same, I'm going to go ahead and cancel that out. So I have x to the third equals 64. I take that to the cube root, x equals 4. Please bring in questions for tomorrow's class. That way I have an idea of what you might be struggling with. Thank you.